For nearly half a century, Voyager 1 has traveled farther than any human-made object in history. Since its launch in 1977, the spacecraft has ventured beyond the giant planets, crossed the outer boundary of the Sun's influence, and entered the vast region between the stars. Today, it is more than 15 billion miles from Earth, communicating through radio signals so faint that they require NASA's Deep Space Network to detect them. Every message takes more than 22 hours to reach our planet. For decades, engineers expected Voyager's story to end quietly. As its power slowly faded, instruments would be switched off one by one until the spacecraft finally fell silent. But in recent years, something unexpected happened. Instead of receiving perfectly readable telemetry, mission controllers began noticing unusual data from Voyager's onboard computer. Some of the information arriving on Earth appeared corrupted, while other sections seemed inconsistent with normal spacecraft operations. At first, engineers suspected failing hardware. After all, Voyager was never designed to survive this long. Its computer contains only a tiny fraction of the processing power found in a modern smartphone, yet it continues operating in one of the harshest environments imaginable. Investigators eventually traced the strange transmissions to a problem inside the spacecraft's flight data system, the computer responsible for packaging scientific information before sending it back to Earth. Rather than indicating an unknown object or mysterious force, the issue was linked to damaged memory that caused incorrect telemetry to be transmitted. Repairing the problem was anything but simple. Because Voyager is so far away, every command requires nearly a full day to arrive, and another day passes before engineers receive the spacecraft's reply. A single diagnostic test can take several days to complete. Working patiently, mission specialists developed new software commands that redirected critical code into healthy sections of memory. Against enormous odds, Voyager gradually resumed sending understandable scientific data. The recovery demonstrated something extraordinary. Not an encounter with unknown intelligence, but the remarkable ability of engineers to repair a spacecraft operating billions of miles away using technology developed nearly 50 years ago. Even while solving the computer problem, Voyager continued exploring one of the least understood regions ever visited. In 2012, the spacecraft crossed the Heliosphere, the outer boundary where the solar wind gives way to the interstellar medium. Scientists expected this transition to be dramatic. Instead, Voyager revealed something surprising. Although the density of charged particles increased significantly, the direction of the magnetic field remained more closely aligned with the Sun's magnetic field than many researchers had predicted. The discovery forced scientists to rethink long-standing models of the heliosphere. Rather than behaving like a perfectly smooth bubble, the Sun's protective region appears far more complex, constantly changing as it interacts with the surrounding galaxy. Voyager's instruments also detected variations in plasma density, energetic particles, and cosmic rays. These observations suggest that interstellar space contains invisible structures shaped by magnetic fields, ancient stellar explosions, and the combined influence of nearby stars. Far from being empty, the space beyond our solar system is rich with physical activity. Every new measurement helps scientists understand how our solar system moves through the Milky Way. The discoveries may not resemble science fiction, but they are no less extraordinary. Because for the first time in history, humanity is directly studying the environment between the stars. And Voyager's greatest discoveries may still be waiting farther ahead. As Voyager 1 continued its journey deeper into interstellar space, its discoveries became even more remarkable. Beyond the Heliosphere, the spacecraft entered an environment unlike anything humanity had ever measured directly. Instead of finding an empty void, Voyager detected a region filled with charged particles, plasma, magnetic fields, and high-energy cosmic rays moving through the galaxy. These measurements revealed that interstellar space is constantly changing. The density of plasma rises and falls. Magnetic fields slowly shift direction. Cosmic rays become stronger or weaker depending on conditions created by distant stars and ancient supernova explosions. Scientists now believe our solar system is traveling through a complex interstellar neighborhood rather than a featureless vacuum. Every kilometer Voyager travels provides another piece of that puzzle. One of the mission's most valuable instruments measures plasma waves. These tiny vibrations move through ionized gas, allowing researchers to estimate the density of material surrounding the spacecraft. Sometimes these measurements are converted into audio, leading people to describe them as the sounds of space. Although they may sound mysterious, these are natural physical vibrations, not voices, signals, or evidence of hidden civilizations. They are another reminder that even the emptiest parts of space remain surprisingly active. Keeping Voyager alive has become one of the greatest engineering achievements in space exploration. Its radioisotope power source slowly loses electricity every year. To extend the mission, engineers have carefully switched off heaters and scientific instruments while preserving the systems needed to continue collecting valuable data. Even routine maintenance has become incredibly difficult. Because Voyager is now so far away, every radio command requires more than 22 hours to reach the spacecraft. Another 22 hours pass before its response arrives. A single troubleshooting procedure can take nearly 4 days. Yet despite these challenges, Voyager continues returning information that no other spacecraft can provide. Its observations are helping scientists understand how the heliosphere shields our solar system from galactic cosmic rays and how our stellar neighborhood interacts with the wider Milky Way. Beyond its scientific achievements, Voyager also carries one of humanity's most meaningful messages. Attached to the spacecraft is the famous Golden Record. It contains music, greetings in dozens of languages, natural sounds, photographs, and images representing life on Earth. It was never intended as proof that someone would find it. Instead, it serves as a symbol of curiosity, hope, and exploration. Long after its instruments fall silent, Voyager itself will continue traveling through interstellar space for millions of years. It may never encounter another civilization. Or it may drift forever through the darkness without being discovered. Either way, its journey represents one of humanity's greatest accomplishments. The internet is filled with dramatic stories claiming Voyager has detected alien structures, mysterious barriers, or intelligent signals. Those claims are not supported by scientific evidence. What Voyager has actually discovered is something equally inspiring. It has shown that the space beyond our solar system is dynamic, structured, and far more complex than scientists once imagined. Every new measurement improves our understanding of the galaxy we call home. And perhaps Voyager's greatest lesson is this: exploration is not about proving extraordinary theories. It is about asking better questions, testing ideas with evidence, and pushing farther than anyone believed possible. Nearly 50 years after launch, Voyager 1 continues doing exactly that. Its mission reminds us that the universe still holds countless mysteries waiting to be explored. Not because we already know the answers, but because we are finally reaching the places where those answers can be found.